Hello and a very warm welcome to our today's webinar called How Do I Bring Level to My Requirement Chaos? My name is Alexander Vollner. I'm going to be your moderator for today. Just some background information. I work as a consultant for Process Fellows. Later on, my colleague, Mr. Timo Karasch, will be presenter of the content-wise slides. So before we start off, let's have a few words about Process Fellows, some organizational aspects, as well as our upcoming trainings. So I hope you might all know Process Fellows. We are a consultant company in the automotive industry. Our name is already indicating that we have a favor for processes and as well process improvements. That's why I would say we are all process experts, especially for the R&D processes. Let's have a look at our services. But before we come to that, just want to recently mention that we had our 5th birthday this year. So basically, we offer 4 services. On the one hand, of course, we have the assessment topic, which is mainly focusing on automotive spies, but as well also gap analysis and potential analysis. We also do potential analysis for cybersecurity. Next up is the consulting part. So as we are already mentioned, we are all process experts, and this is what makes really fun to work with the customer together and try to develop the best solution possible. We work also in safety critical projects, as well as recently also cybersecurity projects. We also offer coachings. So this is really a hands-on coaching scenario. So really training on job to get your employees up to speed and have a guidance through the whole project. Last but not least, we have a very strong training offer. You can later have a look at our website, which trainings we're going to offer. But let me quickly tell you that we offer automotive spies, assessor trainings, also pretty much all over spies, so hardware spies, mechanical spies, but we also offer functional safety and cybersecurity. And we do offer individual training programs as well for your company. So I already mentioned automotive spies is our major business. But beside that, we are all over the spies model. So of course, mechanical spies, but also hardware spies. But not only that, we also consult in organizational change, project management, Scrum, and the next big thing topic, cybersecurity and functional safety. Let's have a look at our upcoming trainings. So the next one is we have a certified provisional assessor course, 22nd of May until 26th of May. This one will be held online and in English. After that, we have mid of June, our VDA Automotive Spies Guidelines training. And also our Automotive Spies for Cybersecurity model. And I just quickly received information that for all trainings, we still have some slots left. So if you click on our main page, there will be exactly this banner. And if you click on that, you receive all information. So be fast and book your slots for the very interesting upcoming trainings. On our website, if you click on the training page itself, you'll find more detailed information about it. So let's have some organizational topics. Please stay muted during the presentation. And also, if you have questions, we collect them in the F&A section. If you have your English teams, it's a Q&A. And we try to answer them at the end of the presentation. But if it fits to the topic, then of course we will interrupt the presentation and I'm gonna bring up the question then. Our webinar is recorded. But of course, none of your names will display later in the recorded version. You will find the slides as well as the presentation on our website, but also on YouTube. But please be patient. It will take around a week, and then you will find the slide and the presentation. Okay, let me quickly introduce you our presenter for today. This will be my colleague Timo Karasch. I'm sure some of you will know him through some projects you have had with him. So Timo is our certified principal assessor and instructor. His topics are automotive spies, mechanical, hardware spies, but also cybersecurity spies. And besides that, he also consults in functional safety. Regarding requirements, Timo developed in 2008 the requirements butterfly in the Hansa Automotive published version. Okay, so that was it from my side. Now I will hand on to my colleague Timo Karasch and have fun with the presentation.
Okay, so now hopefully everybody's able to see my screen now, my slides. Okay, welcome everybody. First of all, thank you, Alexander, for the introduction, and then welcome everybody to my requirements chaos. In the next minutes, I'm going to tell you a little bit about levels in requirements, about my experiences in requirements engineering here. We already introduced, so let's start directly with the topics. To give you a little bit the impression of what my complete webinar is all about, I collected requirements. I think everybody of you already saw a lot of requirements in specifications, in books, oral affirmations of the people, and I collected some from my personal project now. And first of all, I read what the customer really wants, and he told me it's very, very easy what the customer wants. He just said, I need something to close the door. Yeah, I think this is a requirement like most of you already know here. Very, very precise here. You know exactly what to do. No, honestly, this is really what very often the customer just says, hey, you are the expert here. You need to know how it works. So please, you do it. So I said, okay, please, can you give it maybe a little bit more in detail that I really got a feeling of what you really expect? And if you then dig a little bit deeper in what the customer typically expects, you can see something like this. It's very easy. The closing must start when input button reaches on-site position, a downside position, signal of end position is not reached, and status of variable power is on and ending when input button leaves downside position or input signal is reached, while variable power off should represent a malfunction of the system. What? This is really what you can read in the specifications. It's a lot of information here. You typically need to read it twice, 3 times, just to understand what the customer really expects. Okay, so let's go through the other requirements because I collected more about this product that you see here. So very easy, the closing should be fast. typical customer requirements here. Whatever fast means, just fast. Or a push button shall be placed at the tear-off edge of the trunk. Now I get a little bit an idea. It's something about the trunk here. It's opener of the trunk. Good. Let's have a closer look. The car shall provide both a manual and an automatic closing function. Or the power supply voltage of the electrical engine shall be 12 voltage. The pinch of obstacles in the trunk shall be avoided. The system shall give the user the possibility to execute the closing function manually. When end position is reached, the variable is end position shall be set to true. And finally, the system shall stop closing if obstacle has been identified. So yes, we have a lot of requirements here. And hopefully now you know what I mean by requirements chaos here. So let's try to bring order. Let's try to bring some levels in this complete bunch of requirements here. And therefore, I like order, and this is why typically I try to use a kind of shelf. So here is my shelf for today. You see, at the moment, it's completely empty, but together with you, I will try to put now the requirements that we just saw in this kind of shelf here. And this means at the very bottom, we try to get an idea of input requirements that you have. So what are customer requirements? Here, something that the customer really expects, and other input requirements like internal requirements or requirements coming from standards. So these all are the so-called stakeholder requirements that we typically collect. Then based on this, we can see the next part. This is where we talk about system requirements, something our system, our trunk opener really should ensure at the end. And on the highest level, you see software, hardware, and mechanical requirements. So we try to bring them in this kind of order. Okay, moment. Just a second. I think there's something missing. Oh, you see, I skipped a part. Maybe we can come to it later to see what is missing in my shelf here at the moment. Let's start at the lowest level. Let's talk about stakeholder requirements. So my idea, how can we collect, first of all, the stakeholder requirements to identify them? And there is a very simple approach. You can see it in a couple of books already. First of all, because it's stakeholder requirements, we need to identify who are our stakeholders, who has given us requirements that we need for development. And the best way to identify first your stakeholders is to know who is your customer. Yeah, maybe you have more than one customer. Maybe you have an internal or an external customer, but as well, besides the customer, to see a little bit what is expected by internal departments, yeah, like marketing or like standards, or coming from the law, what is expected or what is really requested that you should follow in your project here. Now, when you know who are the stakeholders, you can collect their ideas, their wishes, their requirements, and to be really have a kind of starting point here, try to define the goal, first of all. Yeah? Try to get an idea of the goal and try to explain it in your own words. Remember the page with all the requirements here? So you have to read through a couple of requirements, but please say in one word, hey, our goal is to develop a trunk opener, for example. This is what the product is all about. And then when you know with this goal in background, go into the expectations of the stakeholders, you can see really characteristics. So something the people really want or expect from you. And a very good way to do this is a model that is called the Kano model. Maybe some of you already know it. I think it would be too long to explain the complete model here, but the basic idea is when you check the requirements here that you can see some basic characteristics, so something your product need to fulfill, first of all, just to make sure it works. Then you have a couple of functional characteristics, so something that is really expected to work exactly in this way, and then some add-on characteristics, something to make the customer happy, so something that shows you are something or you can provide something special here. So this gives you an idea of really the expectations here. And to go through this approach, just make sure you use a couple of methods here. There are a lot of methods like creative methods or observations, questioning, yeah, how to collect all this information, all the requirements and all the requests. I think the most important stakeholder here is the customer, because not because the customer is very important, but the customer is the one who's paying the money at the end. So this is why you take care for the customer. How to work with the customer during this approach, and this is where I'm going to show you a little bit how to negotiate typically this idea of the customer. You receive the information, the requirements, and you try to read and understand the requirements first of all. Here, go through it. And when I say you try to understand, you already take some notes here. You set a status and you write comments to your requirements that you collected here. And this means, what do you accept? So you say, yes, this is what I can do. I will do it. What do you reject? And then why do you reject? If you say, hey, this is something we cannot do, or this is not in our scope here, then explain why. Or where do you need more information? Where maybe do you have an alternative, a better solution here? And this is what you give back to the customer, and then you wait for the customer answer to your feedback. Hopefully it will be soon, and the customer will then tell you, okay, reject, let's cancel this requirement, or you have an alternative, okay, let's do it, and then document this as a result of the discussion here.
So Timo, we all know a customer has a big wish list and we have many input documents. Do you have any advice how to bring some system into the whole chaos?
Oh, thanks. Thanks for the question, Alexander. Yeah, I do have an idea. And to be honest, I already had this idea about 15 years ago when I published the requirements butterfly. And here is my butterfly. It looks slightly different than 50 years ago. It grows up a little bit, but this requirements butterfly should give you an idea of how to have a structured way to this process. And it divides this in 4 phases, and it's a collection, then bundle, transfer, and detail. Let's have a closer look at the details here for the 4 steps. Let's start with the collect. Collect means you collect all inputs, all the sources, all the documents that you need. And this is what you can see on the very left here. I have a couple of inputs, customer specification or laws and standards. And you start to manage them in a list or in a kind of database to be able to prioritize them. So we store it here somewhere in the database, and some documents are more important than others, so they will have a higher priority. After this, you start to bundle, because it's not possible that everybody's reading everything here. You do not have the time. Bundling means you create bundles and assign them to, for example, domains. This is where you know, hey, this out of those documents we give to the hardware department, to the software department, to the testing, or maybe to quality here. And this is bundling, and you can see already this is where they are able to set the status. This is what I showed you on the previous slide. And based on this, we go to the right side of the butterfly. Transfer means you see again, we have the goal here. So this is what I showed you on a previous slide. Define the goal based on what was expected here. And we then identify existing solutions, and we try to map these solutions to the bundles that we have on the left side. These are typically already addressed by domains. So you see there's a certain functionality expected, or a certain problem is defined, and we have already an idea, or we have an existing solution here. And then at the very end, in the detail, you detail the requirements based on the solution ideas. And you can ensure really a kind of reuse. So you see it's coming out of the database very often, that you see, okay, for this solution, we already have something here for the software, for the hardware, or for the mechanical development, and you can reuse part of this. This is the basic idea of the requirements butterfly, to help you really to go through the process, and it should speed up a little bit this time that you need for the analysis of the requirements here. here, for more information about the butterfly, here, please come later, and I'm happy to answer some questions here. But I think it's time to go back to our shelf, and here it was empty so far, but we can put now in the first requirements, and this is what we have as an input. So the car shall provide both manual and automatic closing function. So you see
Timo,
this. Yep.
I have here a question which suits to the butterfly. Maybe we can come back to the butterfly.
I can do.
One member of the chat is asking, can you define who is responsible based on your experience for each phase of your butterfly?
Oh, yeah. So who's responsible? You see, it's a lot of work, and it's you have to handle a few thousand of requirements very often, and this is why it's helpful to have a kind of requirements manager in your company. So not someone who is really in detail of each and every step, but who has the overview here, what is needed, and who can really provide them this information, this bundle, for example, for those people. So here, my best solution would be have a kind of manager, requirements manager here.
Okay, thanks, Tim.
Okay, good. So here, coming back to the shelf, I already showed here the first two requirements are put in. So the car shall provide both manual and automatic closing function. This is a real customer requirement. This is where we can seek now for an idea of a solution, and the pinch of obstacles in the trunk shall be avoided. So this is kind of safety goal that is given maybe by the customer or maybe given out of a hazard analysis and risk assessment already, but this is as well an input that we need for our system level. So let's start with the system level, and talking about requirements, I can tell you there are two main activities in requirements, and this is specification of requirements and analysis of requirements. So specification of requirements, I have my requirement specification here. So, and what I should really recommend now for you is, first of all, use attributes. It's only an example, but it gives you already an idea of the most important attributes. Here, to have an ID, I think everybody knows that they are uniquely identifiable. A type, what is a requirement, a header, or an information, maybe the requirement itself, the text, the origin to know where it comes from. Here you refer to this list, to this table of input documents. Class like functional, non-functional, a release for prioritization of requirements, a domain that you know who is in charge to analyze this requirement and to take this requirement on the next level to think about the details of solution here. Then maybe already an idea of what function is responsible here, what software, hardware, mechanical function, what component of the system maybe is relevant here. So this should be part of the control, for example, here. An ASIL that is already defined, or maybe the relevance for cybersecurity. Then ideas how to verify, what methods to be used for verification, for example, and comments given it out of the analysis of the requirements. So make sure you have a set of attributes that is helpful for you to document the relevant information in the requirements. Next recommendation, use patterns. Here that the text should be written in the same way. A good requirements book is nothing that you really like to read here. Requirements is something that you should read when you go to bed, because after the second requirement you already fall asleep. Here it's so boring, but this is what requirements really should be. So patterns like the system should or here shall do something, should be able to do something here. Then use styles, so languages like natural language, here really talking about words, or formal, using diagrams, models here, or semi-formal, a kind of mixture, and use quality criteria here, or rules for requirements. And typically it's separated for internal and external. So internal means Each and every requirement should be identifiable, consistent, reliable, realizable, and so on. So there are a couple of more criteria that you should use or that you can use. And external criteria means for the whole document. The complete requirement specification should be complete, understandable, because you need to think about who's going to read this document. So, and while you write down all these requirements in your specification, you as well have to think about, hey, we need to analyze those requirements. And therefore, I bring you the 4 most important methods here for analysis of requirements. First of all, analysis itself here to ensure the completeness of your specification, to see whether requirements are missing or to derive further requirements. You perform analysis methods like interface analysis. Here, do we have all requirements for the identified interfaces here, or failure analysis? Is our system able to identify a mail function, or is it able to react on this mail function? And out of this, you can see you derive typically more on new requirements. Then models. You can use models already in requirements to make sure the requirements are realizable, and you have already a kind of validation of the described solution, so you can see whether the solution really leads to what you expect. And this is a kind of visualization that you can do here, and you can then use it as an analysis of scenarios of use cases, for example. Then a good idea already to think about verification criteria to ensure it's verifiable, but you have as well something that a tester can then really use a kind of input for the test case creation to make sure you already have an idea about measurements, values, or ranges. Here's something that should be ensured to have the requirements more precise, but as well to see what is the test level or a method that should be used that you can use for already planning of the tests later on, or of the organization of test. And last but not least, the classical reviews to ensure the fulfillment of this criteria I showed you on the previous page, and to check the consistency of the requirements against its inputs. So using checklists with those criteria for walkthroughs or inspections, for example. So this is how to bring together ideas of specification and analysis here.
And also, is there a clear separation between requirements and the system architecture?
Good question. So if you check now, the books will always tell you, please here, requirements is only the problem description and the architecture is the solution, and there's a clear separation always. But in reality, you can be sure it is a kind of mixture very often. So you have iterations, and in reality, both processes, requirements and architecture, they will work very, very closely to each other. I try to show it here. So you already saw in my requirement specification that I assigned a component or a function in a certain attribute here for the requirements. And based on this, you have already an idea to jump to the architecture. You describe all the components, all the functions now in your architecture. So you allocate the requirements in your architecture. You derive the architectural decision, what components you need out of this specification. But then there's a function to be realized, so you need to bring the components in an order to have a solution for this problem that you described in the requirements. And this means you will have interfaces, you will have dependencies, how those components work together. And when you see those interfaces, you're back at what I saw or I showed you on the previous page. When we talk about the analysis of interfaces, you can derive now further requirements for exactly these functions or exactly these interfaces. And this brings you back now here to the assignment here. So this is why you have a lot of iterations here. So requirements lead to an idea in architecture. Architecture leads to more requirements that you need. And so both processes run more or less in parallel here. Good. This is the system level. So back to our shelf. And on our shelf, I try to assign now the system idea. So the system shall give the user the possibility to execute the closing function manually. So this is derived out of what the customer expects. The system shall stop closing if obstacle has been identified. What you see is it's nothing about a real solution here. It's an idea, but we see not who is responsible really to here bring this to reality. It's not really concrete yet. It's only that we take it over, that we have a kind of here task for the domains now. Let's come to the domains, so the highest level here. And the easy part, first of all, is that on domain level, you can see the methods that you can use are exactly the same. Remember, we talked about specification requirements and analysis of requirements. So specification of requirements, it doesn't matter whether you work with system, software, hardware, mechanical, or maybe even other requirements. Here, you have to use attributes, maybe patterns, something you should use, the quality criteria. So it's exactly the same. What is different is a kind of content. And this is what I try to show now here as a kind of difference. When we look in the software specification typically should give you an idea of what is the purpose and the structure of the software. So the first question you should be able to answer, the software in it, what is it all about? Why do we need software inside here? Then talking about functions and elements, here already get an idea of functions within the software to hand over to an architecture later on and define a couple of constraints. Performance, for example, maybe something about resources, so something that is specific for the software. In the middle, we have the hardware specification, and this as well needs a purpose. So we have hardware in. Why? Especially if you have more than one hardware component that you know, okay, what is the purpose? What is the main idea of this hardware component here? And again, functions, capabilities. And here we talk about characteristics, robustness, maybe the behavior for certain temperatures here, or the place here that you have here for the hardware. So concrete, what you then need as a kind of input for the architecture later on. And mechanical. So for the mechanical specification, again, we talk about purpose and maybe structure to bring it already in a kind of order here, what you need in here in the mechanics, the elements, the capabilities, and again, some characteristics like criticality or maybe something about the material that you need to use, or maybe even something about how to check, to test this kind of materials at the end. So it is the same basic idea, but it's slightly different in the content. And the real idea is when we talk about requirements, again, there is not always a clear separation of what is requirement and what is the architecture later. Please have in mind that very often during the architecture, you will identify further requirements for the software, for the hardware, for the mechanics. And very often it is not able, or you're not able to put this somewhere inside here. If you had a model of the software with layers, or whether you have a layout drawing of the hardware, or you have a CAD model of the mechanical, it's not that you can put all this information that you identify in this kind of model or picture. This is where you jump to the requirement specification, maybe have a separate chapter here and make sure you specify this particular requirements here in this specification and assign this then to a kind of test level where it should be checked. So same idea than on system level, but the structure or the content is different here. Pretty much the same for the analysis of requirements. So the recommendations from the system level are the same here, talking about review activities or usage of models and so on. But what is important in analysis for the software requirement is that you, for example, check usability or reusability of standard components. You can already see, okay, we can have a function that can be completely reused or that can be used from a standard, or interfaces to hardware coming from the system architecture. And then now you can see on software level. So can we interact with the hardware as defined in the interfaces? Otherwise, we need further requirements here, or we need to give more requirements using the system level to the hardware. And the verifiability, sorry. So verifiability by automated tests. So you're still in requirements, and maybe you can see if we define the requirements slightly different, we can have automated tests. It is easier, it is faster than only manual tests here. Looking at the hardware, again, analysis of hardware requirements to see impact of position, temperature. Here, how does it fit really inside of the surrounding? If it works together with the software, the mechanics. So talking about interfaces here, and how can we verify the hardware? Because not everything can be done in a real physical test. Very often you can see that requirements can be already verified by a kind of simulation or a calculation. And this is something you can identify in the requirements already to see, yes, please, we do it this way. And then maybe out of 10 requirements, 9 are done by simulation, and you have one additional requirement to perform a kind of physical test just to make sure that the reality really meets the simulation here. And this is comparable to what you do in mechanical development here. Again, impact, position, vibrations, something that should be defined, because only if it is defined in the requirements, you can be sure that this leads to a kind of test case at the end. Interfaces to the hardware, like the correct position and verifiability by simulation calculation, here pretty much the same, because you cannot test everything physically here. So that's the idea of specification analysis on the domain level now.
So now we have seen some levels, and I'm asking myself, do you have any advice for traceability?
Oh, traceability. I think traceability is here. If you would ask 10 developers, what do you know about traceability? I think a minimum 9 developers, first of all, will cite or throw before they answer. Oh no, no traceability. And I think the reason really is that traceability is something that is expected or that is recommended, but I never met a company that really had a complete idea of how traceability should work. But what really is helpful to have already a kind of concept for traceability, and this before you start to develop, please. And I already bring you this idea of a traceability concept here. So what typically is the idea of a traceability concept? That first of all, you have a kind of purpose. You have an idea of what it is about. Why do you need the traceability? What is it good for? Because traceability, please, is not only for the customer or maybe to make an assessor happy here. Traceability should really have an added value for you working in the project here. And this is something that can be defined because based on the purpose, you can see what are rules and what is the expected granularity of the traceability. You cannot go down to the lowest level always. So you need to define how deep is it needed for which kind of elements here, because maybe for some critical requirements, you need more detailed traceability than for completely reused functions here. Then creation of traces, because this is exactly where most developers struggle. You just tell them you need or you have to create a traceability here, but they have no idea how to do it, how to create maybe a link in a tool or a reference to another information, or how to use a reference maybe to create the traceability. So clear description of how to do it, and then how to use the traces and how to use maybe metrics that you can read the data in your statistics, that you can see what is the percentage of traces here, what is maybe what you can do for impact analysis to use the traceability here, that you can really see, is everything traceable? But please remember, it's not only about linkage here, it is traceability. So even if you see a kind of reference somewhere, as long as you are able to then use this data at the end to see, yes, everything is referenced back to an existing information, then we know where it comes from. We can use it for an impact analysis. Then helpful kind of overview here, what the complete picture looks like. So what are all our levels that we have in reality in the projects with all the requirements, but as well with all the architecture elements and all the testing levels that you have in place. And for those, even the tools, what tools are in use, that you can see what can be connected to what. And at the end, consistency. Traceability can help you to check the consistency, and this is where you can address even how this should work. This kind of traceability concept, yeah, I know it looks like a lot of information, but this is something, define it generic in your project or in your company, use it in the projects. It's very helpful that everybody here can use it, and then you can here get some lessons learned out of the first projects to see whether traceability works with this concept or maybe need a kind of adjustment. Here, close to the end. Coming back to my shelf, it's nearly full now. And we put in the three requirements here. When end position is reached, the variable is end position shall be set to true. So this is a kind of software requirement, really specifying something that the software should do. But please, again, here, the real solution is in the architecture when you see where is this variable, in what component is it realized. Then the second one, the power supply voltage of the electrical engine shall be 12 voltage. So this is a hardware or electronic requirements, and a push button shall be placed at the tear-off edge of the trunk. So this is positioning of a mechanical component, already given an idea of what the architecture might look like. Here it's nearly full. You see, one spot is empty. So let's talk about what is missing. What is the missing part here in my picture? And this is because we have a lot of requirements that we collect at the beginning already, and we have no idea where to put it. So we put it somewhere in the project, and typically we never look at it again. What is it? And I brought you the four most important topics here: testing, quality, project, and process requirements. And for better understanding, again, let's get an example. Testing requirements like the system shall be tested according to VW 80,000. So this is an existing standard expected by the customer. You take it and you say, okay, but we cannot do something for the implementation maybe, so you put it away. No, you store it as well. You make sure you can analyze on the levels whether you need to derive maybe requirements out of this, maybe for the decision on system or on hardware level or mechanical level. And as well, you need it as a kind of requirements in your database to make sure the tests can ensure, yes, we have all the required test cases according to this standard, for example. Or quality requirements. The entire product must be developed with processes which achieve at least a capability level 2 in an automotive spice assessment. Yes, pretty easy. We do it. Quality, we always do quality. Very easy. But then the requirement again is forgotten. No, put it in the system, assign it to the domain. Remember the requirements butterfly, like the quality department, and they know, yes, we need to derive some goals in the quality plan. This is how we make sure we implemented this requirement in our project. Project requirements. The supplier shall report the project status and progress at least every 2 weeks in a meeting. Again, you take this requirement, assign it to a domain project, and they make sure in their project management plan this is handled as a kind of task here. Or process requirement like only qualified tools shall be used for software development. Again, who's responsible, who's in charge? Maybe this is something in your configuration management or tool management where they know, yes, okay, we have a task here. So make sure all the requirements are assigned to the domains. And it's not that you can really trace them maybe in this level of detail that you know from development, but you can see where is it implemented later on. And so this is why we can put it here in our shelf as well. we have this additional requirements. It's across all levels, and this is why it is not really assigned to one particular level. Yeah, that's it. This is where you can see my shelf now is really full here on all the 3 levels. And I know it is hard very often for many projects to really differentiate between what is really the customer idea and what is the difference between the system level, the software, the hardware, and the mechanical level. What I would really recommend, maybe based on this example that I showed you here in this webinar, use it tomorrow. Go to your product specification somewhere and try to get some examples as well. Try to get an example that is similar maybe to this picture here and try to bring it together with the lowest level, the input level, the system level, and with examples for hardware, software, and mechanical here, and maybe even for further requirements for process quality, etc. Because this is then your example that you can share in your company, and I can really promise that it will help many people within your projects to get more familiar with the differences of those specific requirements here. That's it. So thank you very much. And here, so now, do you have any more questions maybe? Because the requirements we already had enough. And this is why I will hand back to Alexander for questions here.
Thanks, Timo. And thanks for the presentation. We do have some questions popping up in our F&Q session.
Perfect.
F&A session, sorry. And maybe we can jump back to, I think it was slide 9.
I can even jump back, yeah, I can do.
It's regarding the analysis of system requirements.
Here it is.
And we have 2 questions here. The first one is, what do you think is the best solution for defining verification criteria? Test engineer or requirements engineer should define it.
Oh, oh, this is here. Good question, first of all. So they should do it together. This is my idea. So what do I mean with they should do it together? The first idea very often comes from the requirements already, because a requirements engineer writing down a requirement already think about, okay, what maybe is an idea, how can we maybe verify, but he will not have the detailed information. So you need a tester as well. The tester given feedback like, yes, we can do it, or this is not verifiable, or in a different way, we could use another method here. I would say the verification criteria is the best way to make sure that requirements engineer and test engineer talk to each other, because both are talking in different languages. But if they start talking together using verification criteria, they can learn from each other. Here, the tester can learn what was the intention of the requirements engineer, and the requirements engineer can learn to improve here the requirements for better verifiability for later. Yeah, so this is really a kind of lessons learned. This is why I say, please make sure both are included somewhere.
Thanks, Timo. And the next question is regarding reviews. So who is performing the review of the system requirements?
So if you ask the many engineers, they will tell you that's very easy. That is quality department's task. No, really. So talking about reviews, who is performing the reviews? So first of all, you have one person that is responsible for the review. And in my opinion, this should be the author of a requirement or the requirement specification. Here, responsible means he needs to schedule the review. He needs to provide the information that is expected, and participation in a review. This means all interested people, or all people who will need to work with the requirements should be included. So when we talk about the system requirements, for example, here, so system requirements, you go down. So means it's good to have some people from hardware, software, mechanical to see, okay, is this something we can understand, that we can use this really as an input for our requirements? maybe even the architecture here. Is it something we can really implement, that we can realize? But as well, you go on the other side of the development, talking about testing here. Okay, is it complete? Can we derive some tests here? But very often you even have to go up. And for system level, going up means you have maybe something like a product owner, here's someone who is in charge of the product itself, who can see, okay, is everything included that we really need for this requirement? And if you have those different disciplines inside of such a requirements review, you can do something that is called perspective-based reviews. Means not everybody is checking everything, but everybody's looking for a certain perspective here. So just one example, if you have a developer here in a review, he's just looking for, is it realizable here? Nothing else, only this particular part. And this is here helping to have different perspective in a review.
Okay, thanks very much. So we just have another question regarding the analyzers. It's a longer question. I'm going to read it. From your experience, what would be the best approach to analyze the requirements to cover all topics required by iSpice in terms of correctness, feasibility, cost, schedule, and so on? What and how can you do it in order to have completeness and in the same time to be a good evidence in an assessment? Some examples would be appreciated.
Wow, that's a long question.
Yeah.
And a very easy answer, it depends. So what is the product we're talking about? Because you can see if you check Automotive Spice, it talks about analysis of requirements. It even talks about analysis of costs or risk. It talks about analysis of influence on operating environment. It talks analysis in kind of verification criteria. So a lot of ideas for analysis are mentioned here, and well, only some of them that are mentioned in Automotive Spice. I think the real problem is that very often they perform a kind of analysis in a project, and if you ask the people, okay, but what are the criteria that you used for analysis here, they say, hey, no idea. Here we just read the requirements and try to identify whether it seems to make sense or not. So my recommendation really to be to cover the ideas of Automotive Spice here is to have a clear, defined criteria first of all. And bringing this together, you can see some criteria can be handled with the same method, but maybe you use a couple of methods. So talking about quality criteria to be fulfilled, okay, we perform the review. Or verifiability, we perform the verification criteria, yeah, analysis by the tester, for example. But as well, talking about influence on cost schedule. And this is where you need to have an idea of clear picture of the criteria, because you cannot say, hey, we analyze costs. Or you could just say, okay, we analyze the complexity to have an idea of cost. To define, first of all, we use 3 levels of complexity, low, medium, high. And then we know for planning of or prioritization of the requirements, we cannot do everything that is high complex together. Yeah. So the idea of covering Automotive Spice is really to, first of all, have a clear picture of these are criteria that you need for analysis, and these are the methods that we use to analyze those criteria. And this is then defined as a standard, please, first of all. Here, this is supported by someone who really got knowledge about this. Again, talking about maybe a requirements manager, and then bringing it into the projects. And last but not least, make sure in this criteria and analysis as well to define where is the result documented, to make sure where should we put it. So is there an attribute somewhere where we put it, or yeah, whatever. So this would be my recommendation here, not going into maybe too much detail about each and every step of requirements here. Hopefully this was helpful already. Otherwise, I would say, please send me an email later and I will try to answer in more detail.
Okay, I have one more question. How would you manage requirement bypass strategy?
Oh, carefully, because you will always have a kind of necessity for a kind of bypass. So bypass means you have, for example, a customer that is already defining very, very detailed requirements for the hardware element or for the software implementation. And bypass would mean you skip the system level, you directly put them somewhere on the hardware level or software level or whatever. The problem is if you really only bypass here, that it might be something that you skip on system level. So what you should do, first of all, please, if you have requirements like this coming from the customer, analyze has it any kind of influence on your system? So dependency to other elements of the system here, or maybe influence on any kind of system functionality. And B, has it maybe influence on testing? Yeah, that you need to perform tests on system level for this. Because if A or B is answered with yes, then you need any kind of requirement, and maybe only a kind of dummy requirement on the system level, that you address it here and you can make sure there's a test. Otherwise, yes, okay, it is allowed to have a bypass. And then I'm back to my, where is it? Sorry, I did not want to jump. Then I'm back at my traceability concept, because this is something you can address in the traceability concept as well. Under what circumstances is it allowed to do a bypass of requirements, and how do we create the links? Because otherwise you will not be able to analyze the data of the traceability anymore. So analysis of influence, and then if you do it, define the way of bypass in the traceability concept. That's my answer here. Any more questions?
I think now you are allowed to unmute yourself and ask Timo directly, because in the chat there is no more question.
No more questions.
Okay.
Then we have a lot of requirements experts here. I'm happy. And I'm very interested in seeing your project then in the future, and to see whether it really was helpful for you to work with the requirements in your projects. Thanks a lot.
So thanks again, Timo, very much for your presentation. And yeah, thanks to all the participants. I hope this webinar was very interesting for you. Please check out our trainings, our upcoming trainings, and book your slot. And see you on the next webinar. Thank you very much.
Thank you too. Thank you, Timo.
Bye-bye.
Thank you.
Bye-bye.
Thank you.
Thank you.
Thank you.